little bit longer of a lesson because now we get into the grade 9 topics of stacking. So we start out kind of small in the fact that usually if you're in class, you would see these 1 centimeter cubes, and we would stack it and count it and all that stuff. And most people will just kind of count all the sides that are showing to get it. However, that's not necessarily the best method because you lose track. So it's up to you. I'll show you the method. Again, you can count the sides. Because these are cubes, each side is 1 centimeter by 1 centimeter. All right, so 1 by 1 means each square is 1 centimeter squared area. So that means if I were to count all the showing sides, you can count it, but you do lose track of it. So if you want, try to see if you can visualize how many sides are showing, and for each side it would be 1 square centimeters, and that's what you would get. Alrighty, did you get 14? Okay, so if you can't, like again, usually we'd have the centimeter cubes and then you can kind of like, you know, physically see them. But the best way to do this actually is, does everybody understand that each cube, so I'm going to write this down, each cube has a surface area also, but has a surface area of 6 centimeters squared. And we practiced this with the cubes the other day. One side is 1 centimeter squared, so 6 sides would be 6. So how many cubes do we have? We have 1, 2, 3, which means we would be starting with 18 centimeters squared. But that's not the answer. The answer is 14. So how am I getting 14? So does everybody see that this side right here that I'm highlighting and this side right here that I'm highlighting, I'm actually counting twice. I'm counting the one with the cube 1 and 2, and then I'm counting double the 2 and the 3. So what you have to do is then you subtract the overlap. So then subtract overlap. And the overlap is, of course, one side is 1 centimeter squared, but because it's counted twice, there's one on this side and one on the other side. It's hard to show on a video, but anyways, so that means for each touching side, it actually is 2 centimeters squared that we're covering. And because we have, so that's the double, and then we have the other one that's touching between 1 and 2. So that's another 2 centimeters squared that we're double counting, which brings me to 14 centimeters squared. So this is a little bit tricky, but if you understand it this way, it'll actually make way more sense going forward with the other objects, because you're not going to be able to count sides and stuff like that in complicated objects. So I'll do that again. Let's do B. So if you want, you can try it on your own, pause the video, and then see my answer. I'll explain. So the key here is you take the total and you subtract double the overlap. I'll call it OL. Okay, so my total surface area, that means if they were all separated, would be 24. How did I get 24? Well, there's 1, 2, 3, 4, and each cube represents 6 square centimeters. 6 times 4 is 24. Then I have 1, 2, 3 sides that are covered, and I have to subtract. So that's 3 square centimeters. So I got to subtract double that, which would be 6. So that right there is 3 times 2. So then I get 18 square centimeters as my area for B. Okay, so why don't you try C and D, and then I'll go over it. All right, so what did you get for C? The answer is 18. So again, there's 1, 2, 3, 4. 4 times 6 gives me 24 total to start with. Then I have 1, 2, 3 times 2 for the double the overlap. So 3 square centimeters is the area. Double that is 6. We subtract, we get 18 square centimeters. Okay, did you get D? What'd you get? The answer is 22. Okay, how did I get that? There is 1, 2, 3, 4, 5. 5 times 6 square centimeters gives me a total of 30 to start with. Then I have 1, 2, 3, 4, and then times it by 2 for the overlap. Subtract, I get 22 square centimeters. All right, so now we're going to talk about different objects other than those cubes. And a composite object is made of 2 or more objects. So basically, it's the same kind of concept. We're going to find the total, and we're going to subtract the hidden amount to calculate it. So you're already familiar with figuring out prisms for area, surface area. So that's what we're going to do. So to find the surface area of a composite object, imagine dipping the object in paint. The surface area is the area of all the faces covered in paint. So notice over here, this overlap would not get painted. So you would not count that in your calculation. So that's why we do it separately and subtract double the overlap. All right. So does everybody see here that this is comprised of 2 objects? There's a smaller prism and a larger prism. So the first things first is we're going to calculate the smaller prism. So, and we're not even going to bother talking about it's stuck together or anything. We're just pretending that they're totally separate. Don't worry about the side there. Okay, so we're going to do the smaller prism is a 3 by 6 by 6. So if I talk about the front, again, your view of the front might be different than my view of the front, but the front and the back is, I'm going to say it's a 3 by 6. I always like writing it out like this, which is 18, and I'm going to double that, so then I get 36. Then the top and the bottom, that is a 6 by 6, which is 36. Double that because there's 2 of them, 72. Okay, then we have the 2 sides, and you might argue, well, one of the sides is covered up. So the way we're doing this again is we're doing it separately, and then we're subtracting double the overlap. So the side is a 6 by 3, which is 18. Double that is 36. I add it up, and I get 144 square meters. So this right here is 144 square meters. So now I'm going to do the larger surface area, or largest prism, sorry. Again, this is a 6 by 6 by 12. If you want, you can put the 12 there as well. So the front, I'm going to say the front and the back is a 12 by 6, which is 72, 144. Then we have a top and a bottom, which is, again, a 6 by 12, so 72 times by 2, I get 144. And then the 2 sides is a 6 by 6, which gives me 36. And that's 72. I add it up, and I get 360 square meters. So this is 360 square meters. So the total surface area is going to be the smaller one plus the larger one, and then we are going to subtract double the overlap. The overlap is that shaded region here or here. It's very noticeable there what the length of that is, and it is a 3 by 6, which is 18, which means we're going to be subtracting 36. square meters. And that gives me a final total of 468 square meters. Okay, so if you understand this, you can go ahead and try the remainder and then check your answers with my solutions. I'm just going to continue on my way here. All right, so these are two cubes. So cubes, nice. We can actually do this really quick. So we're going to do the big cube. The big cube is a 6 by 6, which is 36, and there are 6 of them, so you have to times by 6, meaning 6 sides. So I get 216 square centimeters. The small cube is a 2 by 2, which is a 4 for one side, but there's 6 sides. So that is 24 square centimeters. And then overlap. The overlap is that part right there, which is a 2 by 2, which is 4, and we don't just do 4. We have to double that. Double. So that is 8 that we're subtracting. So we add, and then we subtract, and we get 232 square centimeters. So it can go quite fast, especially if it's cubes. So take advantage of the cubes and times the size by 6. Okay, so this isn't a cube this time. So again, if you want, you can pause, get your answer, and then check. So I'm going to do the smaller one first. Smaller prism. And when you're doing this, you should be labeling it so it's very easy for any teacher to mark. Right? All right, so the smaller prism, you could say, I don't know, this is the front right here. So that the front back is a 10 by 5, which is 50. Double that gives me 100. The side, again, you don't have to do it in, you can do it in any order. The side, I'm going to say it's a 10 by 10, which gives me 100. Double that is 200. And the top and the bottom is 10 by 5, which gives me 50. Double that is 100. Add it up, I get 400 square meters. Okay, the larger prism, I'm going to do it over here. Most of the time that these are like a 3-mark question. You get 1 mark for the prism surface area, 1 mark for the larger prism surface area, and 1 mark for the total surface area. Okay, so the larger one, I'm going to say this is my front right here. Again, it doesn't matter as long as you keep track of which size you're doing. So that is a 5 by 15, which gives me 75. Double that gives me 150. The top and the bottom looks like it is 15 by 20, which gives me 300. Double that is 600. And then I have a side by side. The side is a 20 by 5, which is 100. Double that is 200. Add this all up, and I get 950 square meters. So right now, I got 2 marks out of 3. To get my final mark, I need to do total surface area is 950 plus 400. Oh, I need to figure out what the overlap is. Does everybody see, I'm going to use red here, that the overlap right here is the same as that side right here, which is a 10, that is a 10 by 5, which is 50. So I am going to subtract double that, which is 200. So my final answer, hopefully everybody else got it, 1250, and that is the square meters. All right. Example 5. Ooh, this is nice because it's a cube. I like cubes. Okay, so the cube is a 30 by 30. Again, you can pause the video if you want to go ahead, which gives me 900. And that is times by 6, I get 5,400 square centimeters for the cube. Then for the prism, I have a 10 by 10, which is 100. That's the, I don't know, you could call it the front or the back, it doesn't matter. And so double that would be 200. Then I have a a 20 by 10, and it looks like there's 4 of them actually. So does everybody see all these sides going around is the same? So if you find out that, use it. Times it by 4, I get 800, which means I get 1,000 square centimeters for the other prism. And now I got to look at that overlap. My overlap is a 10 by 10, which is 100. So my total surface area is 5,400 plus 1,000. Subtract double 100, so subtract 200, and I get 6,200 square centimeters. Is that what you got? All right, the next one is an application of it, and it's a little bit different. So we'll read it here. A loading dock is attached to one wall of a warehouse. The exterior of the buildings is to be painted at $2.50 per square meter. How much will it cost to paint the buildings? Will the bottom of the warehouse and loading dock be painted? No, you can't lift that. So you got to watch when you have real life applications. You cannot lift it, right? You're not going to take a forklift and lift an entire building, right, to paint it. So read the question, understand it carefully, and then go. So we're going to try the warehouse first. Now, watch. For the warehouse, we're not going to do a top and a bottom. We're only going to do one top. So I'm going to put top only is a 30 by 20, which gives me 600. Don't double it. We're not doing the bottom. Then we have the side. I'll go side, side. It looks like it's a 20 by 20, which is 400, and there's 2 of them, so that would be 800. And then we have you can call it the front of the warehouse, or the back of the warehouse where the loading dock is coming off of. And so front, back, that is a 30 by 20. So that is 600, and we have to double that, so that is 1,200. If I add that up, that would be 2,600 for the warehouse, and that would be meters squared. All right, so then we're going to do the loading dock. Remember, the loading dock, we're only going to go top only again. So the top is a 30 by 20, which is 600, and we're not doubling it, it's only 1. Then we have, we're going to call this the front. The front back is a 20 by 10, which is 200, double that is 400, and then the side, I'll call that the side, so that is a 30 by 10, which is 300, and there's 2 of them, so 600. So that looks like it adds up to 1,600. Now, the overlap is that part right there. So maybe I'll do that here. Overlap is a 20 by 10, which is 200. Double that would be 400. Okay, so now my total surface area is going to be 2,600 plus 1,600, subtract 400. Okay, so I'm going to punch that in. Oh. So that's 3,800. Now that's meters squared. That's a total surface area. They're asking you for the cost. So the cost at $2.50 per square meter, if I take that and times it by 3,800 square meters, do you see the units will cancel? Remember our cross-reducing and cross-canceling? So that means if I take that and times it by 250, I will get the cost, which is $9,500 to paint that. Wow.